All right, welcome back to another edition of Algebra 2. Thanks for joining me, guys. Good to see you again. It's section 5.6 this time, the remainder and factor theorems. It's going to be a little bit shorter than the last one. I know the last one was a little long, but this is going to be a little bit shorter, so shouldn't be quite as difficult either, I don't think. Anyway, well, let's get started. Our objectives for today. Number one, we're going to evaluate functions using synthetic substitution. Remember when we did synthetic division a little while ago? Same thing. And then secondly, we're going to determine whether a binomial is a factor of a polynomial, and we're going to do that by using synthetic substitution. So we're using that synthetic a little bit here today. All right, first of all, remainder theorem. Okay, what we've learned before is we've said, hey, you know, if, well, this is weird. Oh, I know why. I don't have my pen, that's why. That's why it looks different. Before we had this function, f of x equals negative 3x squared plus 5x plus 4. We said if we wanted to find f of 3, what did we do? Well, since 3 was in place of x up here, wherever there was an x here, we put it in. So we would have done this, right? We would have said, well, that equals a negative 3 times 3 squared plus 5 times 3 plus 4. And then we would work this out. 3 squared is 9. 5 times 3 is 15. And then we get here that this is negative 27 plus 15 plus 4. And so altogether, that's going to give me what, negative 8, it looks like, if I'm right there. Negative 12 plus 4, it looks like negative 8. Okay? I'm going to just double check here. All right, good. So now that's the kind of the way we've done it before. What we're going to do now is we're going to use that synthetic division. And if you notice here I've got here that we're going to divide that same polynomial by x minus 3. And so then what does that mean? When I set this up, what's going to go in the box over here is going to go positive 3, right? Because x minus 3, that's where we change it. The number here, negative 3, 5, and 4. So when we do this, remember negative 3 comes down. Negative 3 times 3 is negative 9. Negative 9 plus 5 is a negative 4. Negative 4 times 3 is a negative 12. And negative 12 plus 4 is negative 8. Do you notice anything there? It looks kind of familiar. The negative 8, look, it's the same thing as up here. That's going to work every time. So basically, the remainder theorem says that to find, to evaluate a function here, instead of plugging this number in, now here it wasn't terribly bad, but sometimes the numbers are pretty big and it's a little harder to deal with this way. This is another way we can do that, sometimes a little more simply. But whatever we get for our remainder when we do synthetic division, that is the, the solution there when we try to evaluate that function. It'll happen every time. Okay? So pretty cool, huh? So let's look at a few examples here and see what we can do. So remember, if we're going to evaluate f of 3, then, now, I should have mentioned here as well, I don't know if I can go back on this. I should have mentioned here as well that notice here when we divided this, we divided it by x minus 3. We've done that before. But then I put in positive 3. Remember, we changed it. When it's in this form, the x minus 3 form, that's where we change it because we want to find out that x equals 3. But when it's in this form here where it's like f of 3, like this, it stays the same there. Okay, so we're not going to make this a negative 3. This is going to be a positive 3 here. So depending on what form it's in there. So here's our numbers. 3, negative 6, 1, and negative 11. Bring the 3 down. 3 times 3 is 9. 9 minus 6 is 3. 3 times 3 is 9 again. Plus 1 is 10. 10 times 3 is 30. And then 30 minus 11 looks like would be 19. And so f of 3 would equal 19. Pretty simple, huh? All right, hello guys. Mr. Anderson from the future here. I hate to break in here, but I was taking a look at things, and Mr. Anderson from the past made a little mistake on this next example here, so I thought I'd have to step in and correct the mistake. So anyway, just real quickly, let's take a look at this second example here. We've got f of negative 1, and so that's what's going to go in the box here. And then we've got 4. There's no y to the 4th, so we're going to put in 0. Then we've got 2 for y to the 3rd, 1 for y squared. Notice there's also no y, so we're going to put in 0 and then negative 1. Okay? Be real careful about putting those zeros in. Got to pay real close attention. All right, so let's bring the 4 down. 4 times negative 1 is negative 4. 0 plus a negative 4 is negative 4. Negative 4 times a negative 1 is positive 4. Add those, we get 6. 6 times a negative 1, negative 6. Add those, we get a negative 5. Negative 5 times negative 1 is positive 5. Add those, we get 5. 5 times a negative 1 is negative 5. And we end up with negative 6 as our remainder. And so that means that f of negative 1 equals negative 6. Okay, so that's what that one equals. I now return you to Mr. Anderson of the past. We want to talk about the factor theorem. Okay, so this is the other part that we got to talk about. Sometimes these things that they give us here can get a little confusing. But basically what this means here, it says the binomial x minus r. Remember in the first example, I think it was like we divided by x minus 3. Basically what it's saying is this x minus r, that's like the x minus 3, or if you have x plus 2 or whatever. It just says if you divide it out and you get 0 for your remainder, then this x minus 3 is a factor. That's basically what it says. So if you divide it out and you get 0 for a remainder, then it's a factor. Okay, so let's look at a few examples there. So here's the kind of problem that they'll be asking for. They'll say determine if x minus 3 is a factor of that polynomial, and if it is, then find the remaining factors, okay? Which means we might have to factor it down a little bit, okay? All right, so let's start out with this by seeing if this is a factor. We do it by synthetic division. So since it's x minus 3, we put a positive 3 in the box. And then remember our numbers here. It's 1, 4, negative 15, and negative 18. Okay, now remember, if this works out to be a 0 remainder, then we know x minus 3 is a factor. Okay, so let's do this here. 1 comes down. 1 times 3 is 3. We add them, 7. 7 times 3 is 21. Add them, 6. 6 times 3 is 18. Yay, look at that. 0 for a remainder. So what this means is that x minus 3 is a factor. So I guess we could say, yes, x minus 3 is a factor. Now, how do we find the remaining factors? Well, basically what happens is when you divide this out, it takes this polynomial and gives you this left over after you divide it. So in other words, remember, if x minus 3 is a factor, that means if I took that x minus 3 and multiplied it by what we have left, then it would give me what I started with. So what's left? Well, remember, if you start with x to the third, this answer here is going to start with x squared. Then it's going to go plus 7x plus 6. That's the remaining factor, or factors. We might have to break it down further. But this is called a depressed polynomial, not because it's sad and lonely, but because you took the exponent here and you depressed it or took it down one level. I didn't come up with it. All right, so here's the key though. We found that x minus 3 is a factor. We just have to figure out what's left, is that a factor or not. Well, you know what we can do? We can factor it down, or actually we have to find out if there are other factors. So we can factor it down further, perhaps. If I have 3 terms, what kind of factoring am I going to do? Trinomial, right? So I'm going to say no number in front of x squared, so I'm just going to go 2 numbers that multiply to be 6 but add up to be 7. 6 and 1. So what's left will factor down to be what? X plus 6 and x plus 1. So here's all the factors all together. When you write your answer out, if you want to write all of these together, you can. Technically, they said, is x minus 3 a factor? And if it is, find the other factors. So if you wanted to only give the x plus 6 and x plus 1, that's fine. I think that's how they might give it in the book. But those are all the factors. So this trinomial, or this polynomial up here, I guess there's 4 terms, that will break down into x minus 3 times x plus 6 times x plus 1. Okay? One more, and then we're done. Same thing. Is x minus 5 a factor of this polynomial? And then find the remaining factors. All right, so what goes in the box? Positive 5. What are our numbers out here? We start with 1, negative 7, positive 7, 15. Okay, bring the 1 down. 1 times 5 is 5. Negative 7 times 5, or negative 7 plus 5 is negative 2. Negative 2 times 5 is negative 10. Add those, you get a negative 3. And negative 3 times 5 is negative 15. 0 remainder, yay! So that means this is a factor. So yes, this is a factor. And what's left? Well, remember we had the x minus 5. And what's left here is, remember the depressed polynomial? The depressed polynomial. It's not x to the third. It goes down 1 to x squared minus 2x minus 3. Now, can this be factored down any further? Maybe. Let's see. Can we find anything that multiplies to be negative 3 but adds up to be negative 2? Well, we could make this negative 3 times 1, right? Negative 3 times 1 is negative 3, but negative 3 plus 1 is negative 2. So that means this will break down further to be x minus 3 and x plus 1. And again, if you want to include the original factor there, that's fine. But those are the factors of that polynomial. Okay, so that's all we got in this section, is using synthetic division or synthetic substitution to evaluate a function, and then using synthetic division to see if a binomial is a factor of the larger polynomial, and then we might have to factor to take what's left and break that down a little bit further. So there you go. that's section 5-6. Thanks for joining me, and have a great day. I'll talk to you later. Bye.